This is Algebra 2, Unit 7, Lesson 5 on even and odd functions. Now, functions are simply rules that convert inputs into outputs. So these rules get placed into various categories such as linear functions, exponential functions, quadratic functions, etc., based on shared characteristics. In this lesson, we'll learn another way to classify some functions that have useful symmetries. Okay, so what we're going to look at are even and odd functions. Now, these are the formal definitions of even and odd. A function is known as even if f of negative x equals f of x for every value of x in the domain of f of x. And a function is known as odd if f of negative x equals negative f of x for every value of x in the domain of f of x. Now, that looks kind of confusing. All right, now let's see if we can break this down and describe what this means. Okay, a function is even if. Now, notice right here, we have f of negative x. So that means our input is going to be opposite. So opposite inputs. Opposite inputs, when you put them into the function, you end up with f of x. All right, so opposite inputs, which is the x values, give the same output. Okay, so that is going to be the y values. So basically, if you have a value and you put it in its opposite, you're going to get the same thing. So you put one value in, you get the function. You put the opposite of that value in, you're going to get the same function. Okay, now, odd functions. Notice this is opposite inputs again. Opposite inputs, again, which are the x's. Give. Now, when you put in a negative value, you're going to get a negative y. It's going to give the opposite output. Which would be the y's. Okay? So if you take a function, you put something into it. If it's odd, you get an output. If you do the opposite of that same input, you're going to get the opposite output. So let's look at it first from a graphical standpoint and see if this makes it a little more clear. All right, now let's consider the partial graph of the function f of x shown twice below. Sketch the other half of the function in A, if f of x is even, and in B, f of x is odd. The three coordinate pairs are listed to help you plot. Okay, now, if a function is even, it says opposite inputs give you the same output. Okay, so 0 does not have an opposite. So 0 is still going to be 0. It's going to give you, if it's even though, it's going to give you the same output. So this is still going to be 0, 0. Okay, if I have the point 3,5 and I take its opposite, negative 3, its output, if it's even, is going to be the same. So 5 will still be 5. And if I have the point 7, negative 2, if I have the opposite input, that would be negative 7, will give you the same output, negative 2. All right, let's plot these 3 points. 0, 0 is already here. Negative 3, 5. 1, 2, 3. 1, 2, 3, 4, 5 is right there. And negative 7, negative 2. 1, 2, 3, 4, 5, 6, 7. Negative 2 would be right here. And I'm going to draw in my values. So this is an even function. Opposite inputs give the same outputs. Okay, so we should notice a symmetry. We'll discuss that in just a minute. All right, now, odd functions. Opposite inputs give opposite outputs. All right, so 0, 0. 0 is still the opposite of 0, is going to give you the opposite output. Opposite of 0 is still 0, so it's going to be 0, 0. Okay, now, here's where it gets a little more working on this. 3, 5. Opposite input would be negative 3, gives you an opposite output. So if this is 5, your output is going to be negative 5. All right, one more. If your input is 7, its opposite would be negative 7. Its output will give you the opposite of negative 2, which would be positive 2. So if I plot these 3 points, 0, 0, here, negative 3, negative 5, 1, 2, 3, 1, 2, 3, 4, 5. And then negative 7, 2 is going to be 1, 2, 3, 4, 5, 6, 7. 2 is going to be up here. And then when I draw my line, connect my points. Here we go. Okay, now notice that the symmetry of each of the graph. All right, for the even graph, when you do an even function is symmetric around what line? It's symmetric about the y-axis. It's symmetric about the y-axis. All right, so if I fold it here on the y-axis, if this is an even function, all right, we know where the points are going to end up. Okay, now an odd function. How is that symmetric? All right, it is going to be basically a rotation. And an odd function, it's symmetric around through the origin, making a 180-degree rotation. So it's a symmetric about the origin, which is a 180-degree rotation. And that makes sense when you think about it, because remember, opposite inputs get opposite outputs, because you get negative x, negative y, and that's the rule for a rotation of 180 degrees that we learned back in geometry. Okay, and same thing for even function, it's symmetric about the y-axis, because opposite inputs give you the same outputs. When you reflect over the y-axis, your x changes, your y does not. So negative x, y. Okay, so when you're doing these problems, if you see a function that is reflected across the y-axis, it's probably going to be, if it's symmetric about the y-axis, I should say, it's going to be an even function. If it's reflected through the origin, it's going to be an odd function. Okay, some of the functions you have seen in your study so far are even, some have been odd, and many have been neither. Let's take a look at a variety of functions and consider whether they fall into one of these categories. So let's look at an absolute value function first. Consider the function absolute value of x minus 4. Evaluate this function for a variety of opposite input pairs. What type, even, odd, or neither, does f appear to be? Okay, so let's think about this for a second. Let's pick a couple values. Let's try f of 2. All right, so that would be the absolute value of 2 minus 4. The absolute value of 2 is 2 minus 4 is negative 2. All right, what is the opposite of 2? It would be negative 2. The absolute value of negative 2 minus 4 is, the absolute value of negative 2 is 2, minus 4 is still negative 2. Huh. Okay, so we have the same output for opposite inputs. Okay, now let's make sure this is going to work again. Let's try 7, just for argument's sake. F of 7. The absolute value of 7 is 7. Minus 4 is going to be 3. And what if we use negative 7? The absolute value of negative 7 is 7. Minus 4 is still 3. Opposite inputs means the same output. What kind of function is this going to be? Opposite inputs with the same output is going to be an even function. Okay, now let's sketch this on the graph. Okay, so first of all, if it's the absolute value of x minus 4, what's going to happen to this function? It's going to be shifted how? All right, from the vertex, it's going to be shifted down 4. Remember, this is the v-shaped function. It's starting at 0, 0, so it's going to shift down 4. 1, 2, 3, 4. Okay, so we know it's going to look like that. We can plot these points right here. 2, negative 2. And negative 2, negative 2. Okay, then we can plot 7 or 5 or whatever we want to do. If we did 5, for example, it would be 5. This is going to go up like this. 1, 2, 3, 4, 5, 1. And negative 5 is also going to be 1. Okay, so when I draw my function in, you can see right here, it's going to look, oops, off a little bit. It's going to look like a V-shaped function that is symmetric about the y-axis. All right, so here's the y-axis. It's symmetric about the y-axis, so it is an even function. So it is even. All right, if I fold on the y-axis, it matches perfectly. So it is an even function. Okay, we will be studying higher order polynomials extensively, not necessarily Unit 10, but coming up soon. But we can take a look at simple cubic polynomial. So let's investigate x cubed minus 4x. All right, so if I get out my calculator, so here's my calculator, and I'm going to put in y equals x cubed minus 4x. So x raised to the third power, forward arrow to get off the cube, minus 4x. And I want to look at my table from -3 to +3. So if I'm going to look at my table, all right, from -3 to +3. So here are my values, -15, 0, 3, 0, -3, 0, 15. Okay, so I'm going to fill in those values. All right, so we have -15, we have 0, we have 3, we have 0, we have -3, we have 0, and we have 15. Okay, so what type of function is this? Is this even or is this odd? All right, so what we want to look at is the opposite inputs. All right, so we want to look at -3 and +3. Opposite inputs. Give you, this is -15, this is +15. Opposite inputs have opposite outputs. Okay, opposite inputs have opposite outputs. All right, is that true for all of them? If I do -2 is 0, 2 is 0. Well, technically those are still opposites when we do that. And then -1, 3 and 1, 3. Opposite inputs, opposite outputs. So what kind of function is this going to be? It is going to be odd. It is an odd function. All right, so let's sketch a graph of g of x using your calculator in the window indicated. All right, so I'm going to reset my window. X's are going to be from -4 to 4, and Y's are from -15 to +15. All right, so I'm going to reset my window from -4 to 4. And my Y's from -15 to +15. All right, and then I want to graph my function. All right, so there's my function. It's kind of a wavy function, and it's going to hit my values here. All right, so it's going to go up like this and come down, and then go up like this, like so. All right, so it's going to look something like this. Okay, so what kind of symmetry is this? Well, if we look at the origin right here, if we rotate this part right here 180 degrees, where do we end up? We end up over here. So this is symmetric about the origin. So it is going to be an odd function. So it's symmetric about the origin. So you can see as it goes up like that. All right, now notice when you do even and odd functions. Even functions are going to point up on both ends. Odd functions point in opposite directions on both ends. That's another way to look at it. So this is going up one way and down the other. This one is pointing up both ways. The ends point the same way is what I'm basically looking for. It's called end behavior. Okay, got one more. All right, is the simple exponential function f of x equals 2 to the x odd, even, or neither? Support your argument with numerical evidence. Okay, so we are going to go over this one in class the next day as a refresher, so save this one, see if you can figure it out.